The first one, which is called change of base, is I am not going to bore you with the proof concerning it. I'm just going to give you what to do. Assuming you have log 9 base 4, log 9 base 4, you can make a choice of the base you like. Probably you want to bring in base 4, you want to bring in base x. It's going to be simple. What you are going to do is say log 9 base x all over log 4 base x. You see that? That is your choice at this point is x, because you want to express this log in base of x. If you want to express them in different bases, that's your choice. You can also have log 9 base 4 can also be written as log 9 base 3 all over log 4 base 3. You see, it started with base 4, but at the end, it has been changed to base 3. Then this one started as base 4, it has been changed to base x and x. That is how it works. So let me give you another example. Assuming you have log 8 base 3, it can be also given as log 8 base 7 all over log 3 base 7. This is your choice. That means you have converted this particular expression of log 8 base 3 into a new log of new bases. That means log 8 base 7 and log 3 base 7. That means base 3 has been changed to base 7. That is the expression called change of base. There is another way of changing base, and that is if you have log 9 base 4. This log 9 base 4 can also be expressed in different ways. You can have 1 all over log 4 base 9. You see that? This is called reciprocal, which is also an expression of change of base. So you change the base, it was 9, you invert it by bringing in 1 all over. It is a proof, which I know I'm not going to bore you because of time. You can also have, if you have log, let's say log 8 base 3 can also be 1 all over log 3 base 8. Now we are going to solve a few questions on how this can be applied. Okay, looking at this problem, look at this. I can apply any of these principles. Also remember, I can also written this or like log 8 base 3, which is going to be log 8 base 10 all over log 3 base 10. Changing from this to this and this. That means log 3 has changed to base 10. Base 3 has changed to base 10 in this expression. So this is a way of changing base, like I've explained before. We are going to apply those principles in this example. Now, if you have this, base 3 and this, they are not the same thing. This is base 3 and this is base x. You need to apply a change of base principle in order to bring them to par and be able to solve. What I'm going to do is, I'm going to say log x base 3 minus 1 over log x base 3 equal to 2. So you see, because of 1 all over, this base and this base are formed the same. That is the essence of change of base. So I'm going to say let log x base 3 be y. So I'm having y minus 1 over y equal to 2. Remember y. So what do you mean? I'm going to clear the fraction. This is all over 1. I'm going to say times y, times y, times y. Why am I multiplying? I'm clearing this fraction using the LCM of the expression. So I have y squared minus y, will cancel y, minus 2y minus 1 equal to 0. In order to clear this quadratic equation, in order to solve it, minus 1 and 2 will not really work. So I'm going to use quadratic formula. I'm going to say y is minus b plus or minus b squared minus 4ac all over 2a. So b is, this is my b is minus 2, and this is my c, and my a is 1. So I'm going to have y is equal to minus minus 2. B is minus 2. So minus b. B is minus 2. So this is going to be plus or minus. Minus 2 square minus 4 times 1 times minus 1. Minus 1. So I have y plus equal to 2 plus or minus 4 plus 4 all over 2a. Y is going to be 2 plus or minus square root of 8 all over 2. All over 2. So y is going to be 2 plus or minus 2 root 2 all over 2. Remember 8. I'm saying this 4 times 2 is equal to root 8. Square root of 4 is 2. So that is why root 8 turned to be 2 root 2. So I have that y is equal to 2 plus or minus. Okay, so I'm going to have plus 2 root 2 all over 2. Y is going to be 1 plus root 2. Or y is going to be equal to 2 minus 2 root 2 all over 2. Y is going to be 1 minus root 2. Now remember, these are the expression for this one, but then we are looking for x. We are looking for x. So what I'm going to do is first, since that y is given as log x base 3, so I'm going to say that log x base 3 is equal to one of the expressions, which is 1 this one is the first expression, 1 plus root 2. This is 3 bracket 1 plus root 2 is equal to x. That is what my x is, and vice versa for that expression. But remember, all this I'm solving is not really the main thing, but the main thing I want you to know is how the base could change and become the same by the principle of this change of base. Let's solve another one on the principle called power of the base. Second principle called power of the base of logarithms. It says that if you have log 8 base 5 raised to power 2, the result is going to be 1 over 2 times log 8 base 5. Boom. So it's simply saying that the raised to power 5 is that you invert the reciprocal of the power, we multiply the log. Let me give you another one. If you have log, let's say log 10 base 5 raised to power 3 over 2, this is going to be 2 over 3 times log 10 base 5. You see that? If I will invert the power, you then use it to multiply the log, and the power of the base will be disappeared, will be vanished. I'm not going into proof. Probably I'm going to do a video for the proof, but that's not my intention. My intention is to being able to lose this. Now, finally, what if you have log y base x raised to power 5 over 4? What is going to be the answer? Can you just tell me? Okay, this is going to be log 4 over 5 y raised base x. So I'm just giving you the rule. These are tips. Tips on the rule. The power, this will go up and come down, which will multiply the whole log, and left with the base only. So this is the principle. Let us solve example on how to apply it. Now, if you look at this very well, you realize that the bases are not the same. And that is the first problem you face when you want to solve logarithms. This is this, and this is this. And all of these can be expressed as a base, as a power. So deal with it. So I'm starting with this. I'm going to have log 4 2 raised to power 1 over 2. Remember, anytime you have square root. The answer is going to be 2 raised to the power 1 over 2. So that is why I remove this thing and put it as this power. Then plus log 16, 2 raised to the power minus 1. Remember, if you have 1 over 2 is something as 2 raised to the power minus 1. If you have 1 over 5 is something as 5 raised to the power minus 1. So have it in mind. Then minus log 32 is 2 raised to the power 2. You see? Now, I'm going to apply this principle. The power will invert itself and multiply the log. So you see, 1 over 2 is going to turn to be 2 over 1 times log 4 base 2. Then plus, remember, minus 1 over 1 is something as 1 over 1. That is minus. So this one does not have much problem. Minus 1 times log 16 base 2. Then minus, this is 2. 2 over 1 is something as 2 over 1 means the same thing as 1 over 2. So I'm using 1 over 2 to multiply. I'm going to have 1 over 2 times log 32 base 2. So you see, that which had this, that which had power square root and the problem with in base of 2, which tend to be this, and this, has been reduced to all this. All right? So let's move further. I have 2 log 4 base 2 minus log 16 base 2 minus 1 over 2 log 32 base 2. I have lost them. That is the principle. But then let's finish it. I'm going to have log 4 raised to the power 2 base 2 because this has to climb. That is the power law which we treated in the last example, base 2. And this is going to be 16. I'm leaving it that way. Then minus log 32 raised to the power 1 over 2. Remember, the power law we climbed, base 2. Now, according to the law, when they are having the same base, plus, this one is plus. Plus we times with plus, y minus will be division. Plus is addition, y division, y subtraction is division. So I'm going to have log base 2, 16, because 4 raised to the power 2 is 16, divide by 16, also divide by 32 raised to the power 1 over 2. That is all. All right? So I'm going to treat this as it is. So if you have 16 over 16 divided by, let's just put it this way, 32 over 1 is 16 over 16 times 1 over root 32. 16 will cancel 16, of course. So I'm going to have log base 2, 1 all over 32 square root of that. You know? So this is going to be log base 2, 1 over this is 1 over 2 raised to the power 5 times 1 over 2. You know what that means? Okay, let me break it down. Let me break it down. So I have log base 2, 1 all over 32 raised to the power 1 over 2. Right? So this is log base 2, 1 all over 2 raised to the power 5, all bracket 1 over 2. Now, according to the power law, in indices, look at what indices stated. Indices stated that if you have anything, let's say 2 raised to the power 3, all bracket 3, that the power will multiply power, power times power. So it's going to be 2 raised to the power 3 times 3, which is going to be 2 raised to the power 27. You see? So the power here is 5, the power here is 1 over 2. It's going to be log base 2, 1 over, 2, 5 over 2, because 5 times 1 over 2 is 5 over 2. Now, and this is going to be log 2 raised to the power minus 5 over 2 base 2. All right? So this is the power. The power will fall down. That is the rule. It can climb up, it can fall down. So minus 5 over 2 times log 2 base 2. Log 2 base 2 is 1 because log to its base is 1. So we have minus 5 over 2 times 1, which is minus 5 over 2.